Good morning, Srikanth. Good morning, Guru Prasad. After a long time, we are meeting, and all Fluid Power community and friends. You know what? Last for almost 50 years, I've been doing research, so in various forms, and I'm happy because, as you know, I have been more of a fluid dynamics person, aerodynamics, fluid dynamics, gas dynamics, less of fluid power. But we have used fluid power for every missile. There is either a pneumatic power or a hydraulic power for actuation systems. So we in the Akash has got air pressure, pressurized compressed air, whereas Prithvi and all had hydraulic servos. So we have used the fluid power. And one thing which is, I was just talking to Srikanth about research here, so I told him you should have two big dreams. Like we used to, when we used to work with Dr. Kalam, he used to say, "Do Prahlada, don't think a small, think big. Think big dream, big achievement." So he said, if you want to do missile, do something which is the best of the missiles in the world. Don't do something which you think you can do. No, do something which is the best. So we took Akash and BrahMos. Akash first we did is a multi-target, what do you call it, ranges. And also Army, Air Force wanted these missiles has to be better than Patriot. At that time, the Patriot was the best surface-to-air missile. So Air Force, Army said, I want something better than that. So we have to, our aim is put like that. And we took nearly 12 years to develop it. And then, of course, now the orders have gone to thousands of missiles, and the performance have been validated in the field, in the battlefield, by both Army and Air Force. And we are going to now not only version 1, there is version 2 and version 3 coming up. So already they are 3-layered. So it is a good sort of a, what we felt, I don't know, we never thought one day we'll see war, one day we'll see the missiles working. We used to see the Republic Day parade and Rajpath or missile tanks going, wheel vehicles going, and we were using capped in the house, and we thought that's the best. We never thought one day we'll see a war and the missiles have been fired. So till the May 7th, when the NDTV announced that Akash has done one well and Air Force is happy, then only we realized it went to the war and it was used. So I thought based on our experience with the missile systems, based on the fluid power R&D, I thought some ideas I can share with you so that you can see how to grow. Think big. Think big things. Especially what Srikanth mentioned, Atmanirbharata, we have to do. So I am thinking like this. You have number of companies, many are multinational, many are homegrown companies. And you can't do big things, new R&D, new production, because numbers are small. You want to order some specific pump or actuator, maybe numbers in 20s, 50s, 100. Whereas people are used to mass production, like automobiles, computers, within thousands, millions production. So the multinationals are aiming at a large volume production. But here the local market, Indian market may be smaller numbers. Like a missile or a radar, the order may be 100 radars maximum, 50 radars. But you have to make the best of the radar. Missiles we thought will make 1,000 missiles may be a good number. Air-to-air missile, even 500 is a big number. So we are used to small number, high value products. when compared to car which is maybe 100,000, 200,000 numbers. So their cost becomes primary. Here, performance becomes primary. So something we are also worried. Suppose you make a missile, an air-to-air, air-to-ground missile. Air Force, Army wants 200 numbers, a big number. Then how to produce? You can't mass produce. Fortunately now, we are now having the benefit of additive manufacturing, 3D printing, that enables us to produce small numbers equally competitively, and every customized products can come out in smaller numbers. This advantage you have today, which was not there when we started. There was no method of doing. We have to go for tooling for mass production, but produce only 100 numbers. But today, you don't have to do tooling of mass production. You want to make 100, 200, 1,000, you can go 3D printing. In addition to that, we have now given the Army and Air Force missiles, and we give in batches, no? Lot 1, lot 2, lot 3. Every lot maybe 500 missiles. And these kept in the depot for a number of years, and then they have to periodically test it, upgrade it, maybe change some parameters, maintain it, do some improvement, hardware, software. That has to be done continuously for 30 years because the missile's life is 30 years. 30 years you can't keep the same missile. Some products will get outdated technologically, so you have to do some fine tuning. Maybe use that, see, war has taken place. Army, Air Force has some experience. They will come back and tell, can you do this change? So we have to do maybe for first 500 we are not done, next 500 we will do it. So how do you do? Again, you have to go for additive manufacturers. You maybe remove a component, put a new component with minimum capital investment. This is what we can do. So how do we do it? See, I was talking to him, R&D in fluid power, how are you doing? There is no body like we have got to, when we want to do R&D in, say, hypersonic, we are all hearing. We are making hypersonic missiles. Already we started designing, fabricating. And we don't think it will be more than 200, if at all India makes. So what do you do? So we are now looking at the R&D has to be done. Maybe I make the first few numbers using 3D printing and then test it, modify, upgrade it, make another 100, test it. Like that it may go in this fashion. So same thing we are looking at the product support, lifetime product support by the production agencies for our missiles has to be done in similar fashion, where based on the feedback, they have to go back to the design, make a customized design for next batch, make the hardware, make the software, go and upgrade the existing missile. This is a routine. Every missile, because 30, 40 years it has to be with the user. And he wants, suppose he has got 5,000 missiles, he will not use all 5,000 in any war. At the most, there may be 100 number, 200 numbers used in a war. Based on the feedback, he will upgrade next 500. And those have to be done like what I was telling you, have to take periodic stepwise, customized, improved product has to be fitted. And keep watching the technology scenario, what technology becomes relevant. See, when we made first computer, put in the missile, on-board computer, we used the best available chips and components for that generation. But if you are using the missile for 30, 40 years, definitely they will be outdated in 10 years. You by force, you have to change the computer with the latest chip because it won't be supported by any, checkout systems. Everything you have to change. This is routinely, whichever country is delivering aircraft, for example. Aircraft life also is 30, 40 years. Fighter aircraft, transportation aircraft, or missiles, cruise missile, long life. But the life of a technology or a product is short. Today it is of the order of 5 years. Earlier it used to be 10 years. Today you buy a mobile and 2 years is outdated. Nobody wants to look at your mobile. You have to just junk it. Fortunately, in military, it may be every 5 years. Same concept will be fluid power, because you may have to upgrade your systems in small numbers, but periodically upgrade, depending on the challenge that you face from the user, from the industry. So, but how do you do R&D? See, for R&D, you need a large establishment, infrastructure, qualified researchers to join you and work with you for 10, 15 years. Because no product will be done in 2 years. It takes 10 years. So for 10 years, the team should be there working on it. So how do you do it? So it is a massive, maybe if you are growing in a particular fashion, and I will say that in about 10 years, you have 100 people today, you should have 1,000 people. 1,000 people from the Indian companies, from the R&D centers, from academic institutions. 1,000 people should be in the forum, what you are doing today in 10 years. That should be your dream. We need 1,000 fluid power engineers within the country. It may be massive brute force fluid, it may be microfluidics. We don't know the way microfluidics are moving. You may have many microfluidic devices in radars, in computers, in onboard avionics systems. They may use microfluidic chips. Maybe that will be one of the verticals in fluid power. Not only high pressure fluidics, but vacuum, low power fluidics, microfluidics. Very little flow. For example, I told you we are working on low energy nuclear reaction. We are working under vacuum conditions, much less than 1 bar. And we are inducting and injecting, dosing hydrogen gas in that pressure, 10,000 pascals, 20,000 pascals level. So actually you can count the number of molecules inside the device. But it's important to understand the fluidics, how it moves and how it fuses to generate heat, generate energy. It may be a different fluid power what you are going to talk. When you compare to hydrolysis, or air bottle we are having, or a hydrogen combustion we are all having, 1,000 bar they want to pump hydrogen, put in a car and drive the car. If you have a hydrogen IC engine, hydrogen-based IC engine. Hydrogen-based, if you want a energy device, what we are doing called low energy nuclear reaction, it works at 20,000 pascals. Whereas in a car, you may put hydrogen at 1,000 bar. You see the range of what you are going to handle. So you need a lot of R&D to understand both. So one way of R&D, what we are doing is, we don't have any R&D center for a particular technology. We have only product-oriented centers. R&D is done by academy. IIT Madras, ISA Bangalore, or MS Ramaiah College, or Dharansa, they do R&D because they are getting fresh students continuously. So use them to do R&D, but you monitor, you guide them, you supervise, you validate, you advise, you mentor, get the product from academic till you have your own R&D center. When you have enough money and enough manpower, enough cloud, you can do it. Till that time, use the academic institutions. We have used ISC, every department has worked for a missile program. BrahMos missile program, not only within the Bangalore, within the country, as you know, I was handling the extramural research. So I used to fund 500 universities in the country, 500, all over the country, small deemed to be university, private universities, central universities, IITs. Think of it, we have funded. The research done there, the guidance research they have done, pneumatics research, air intake, everything they have done. But the QRs, quality requirements we are given, we go and monitor, and we see that the result of the research is successful, useful to me in time, and also it can be later upgraded as the time moves. But after some time you want to change, you can change. So this kind of a mechanism we have done. And today we have done, one more thing we have done is, in every major academic institution, we have built or organized a center of excellence. IAC, we have center of excellence. So we have put about 20 centers of excellence by DRDO in 20 academic institutions. We don't have any infrastructure. We only put one person, key person, or maybe two people each center. Our employee, not more than 2-3 people. Rest they will hire locally. They get the faculty members from the local college or the university. Take PhD students, postdocs, hire scientific assistants, JRF, SRF, whatever you want. They build a team, they do R&D. The R&D, real R&D is done in the laboratory of the academic institution. So I don't have to worry about infrastructure, power, water, logistics, everything. No headache for me. But I am getting my research done in ISC using the Center of Excellence. I have got at IIT Mumbai, IIT Madras, everywhere I have a Center of Excellence. So this one model you can see, fluid power, till you have your own independent R&D center, can you use such a concept? Already in IIT Madras, there are many industries. They have opened a center in the research park. You go to Bombay, you go to Chennai, you go to Guwahati. There is a research park established by the IIT, ISC. They want the research park, they have a infrastructure, they have some common facilities, administration, finance, and logistics. And your person goes there, 2 or 3 people. And the rest are hired within the campus. The professor, one professor will come, maybe 2 assistant professor, 2 JRF, 1 SRF will come, they make a team. They are working for you for R&D. Because you are guiding them, you are giving the project, you are monitoring them. And they use the laboratory in the academic institution. They use the brain power available with the multiple departments, not one department. They may be mechanical, they may be electrical, they may be fluid dynamics, aerodynamics, all may be there. But you are getting the benefit of multi-departments. You have only 2 people in one center, so you have multiple centers. Already many multinationals have established centers of excellence like this in multiple IITs, IISc. They fund fully, the budget is fully by the multinational, but the manpower is local. And the company has kept only 2 people. This is one concept you can see. As a fluid power society, you can have a center of excellence in number of places where real strength, the intellectual strength is available. Use the strength, use the facilities of that academy, get your job done. But the IP, you hold the IP. So IP held by fluid power. You can hold the IP, but the work is done by the, and they are not the employees. They are all local research assistants, academic people. So IP held by the company, you are funded, you get all the benefit, you market it not only within the country, you can market for the entire globe, world. You can market to anybody. This is one model I am talking to Srikanth. You can look at it, because you need, if you want to do any research, it requires big team, maybe for 30-40 people have to do work for 2-3 years. You may not be able to do in a R&D center of yourself. You can use the academy. There will be people coming, doing, but you are controlling, monitoring, checking, and getting the job done. This is one, so that in 10 years I can see that you have got many products with IP held by this society, products produced either using mass production or using batch production, using additive manufacturing, and you grow as a society so that the best of the products done in the country. This is what I thought to do. That is where these are dream of our country, not only Dr. Abdul Kalam, today Modi also says, Vikasit Bharat karna hai. That is, we should all have a Vikasit Bharat by 2047. This is the only method you can do, where you use the existing intellectual capability, do in a most efficient way, get things done. This is what we are thinking. So I am happy that to address all of you, share my views, and I'm giving you some homework also. So, and I thank all of you. I wish you all the best, because I know the power of fluid power. It is fantastic. What you cannot imagine. You have a little small valve and use a pump and a storage tank. You can do wonders. So please continue to build a nation, but also build a sort of a ecosystem in the country, which people will say, oh, this fellow done a wonderful job. Which are a small company today. You are a small team, but today you will grow into a big team of maybe. I told you, I want 1,000 people in a conference like this, not 100. This is my dream. So I thank you all of you for sparing your time and giving me a chance to share my ideas, and I wish you all the best. And I always thank, I told Guru Prasad also. See, when the Akash is successful, BrahMos successful, 1,000 scientists have worked all over the country. 1,000 scientists, not in any particular city or every country. And when 1,000 scientists are working, we all had very young people. Most of them, their 20s, 30s. We were also in that age bracket at that time. And I say 15 years they have worked for giving the products. So all the families used to suffer, family members. Because we're all young people, small kid, wife is there, you have to go to school. For example, my wife keeps on telling, do you know there is what is known as parent-teachers meeting? You are not attended anytime. So we never had time to go. So we said the sacrifice of all the 1,000 families have made this happen successfully. So I thank all people. So you also can get the benefit of family support. We said. And now, of course, we are a little relaxed. But now, the time where we were supposed to enjoy with children has gone. They are gone all over the world. So, the sacrifice has given us good result. For the country has given a good result. But some 1,000 families have suffered to some extent, I agree. But that is probably a part of life. We have to work for the nation. So we have done it. Thank you very much for coming here and listening to me. And I want this fluid power to grow in a big way. So I wish you all the best. Thank you.